Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSE in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about question bank on numerical integration. So the first thing is that explain in detail about the bisection method. So when it comes to the introduction of this, it should be one of the most simplest and most reliable iterative method for solutions of nonlinear equations. And this one is also known as binary chopping or a half interval method. And based on the repeated application of this intermediate value theorem. Okay, so the bisection method should be one of the simplest and most reliable iterative method for solution of nonlinear equations. And this one also what we call it as binary chopping or half interval method. So based on the applications of this intermediate value theorem. And this bisection method is going to be given at some interval, so that we should be able to contains the root. And this bisection method will also be cut the interval in two halves, and then where you can able to check half interval contains the root of the function. And we should also keep the interval in halves until the resulting the interval is extremely small. So the bisection method is to be an initial interval of AB where you can able to contains the root, and this bisection method is going to be cut the interval into two halves, and this bisection method will also be cut can able to keep the interval extremely small as well. And this should be this graph of this bisection method. So if f of x is the function and f of a and f of b are the values, interval values, and how the graphs looks like this. And suppose if I'm going to calculate the middle element of this one, so then I can able to obtain the f of m value. So how the middle is going to be obtained by deriving the equation a plus b by 2. And similarly, if I'm going to make the sign of this, we can also be proceed in the same interval. So let us consider an example like x1 is equal to a and x2 equal to b. So let us define a point x0 at the midpoint of a and b. And how the midpoint is going to be calculated? So x0 is equal to x1 plus x2 by 2. So now there exists three conditions. So the f of x0 should be 0 whenever the root value should be at x0, and similarly if f of x0 and f of x1 should be less than 0, then the root is going to be lie in between x0 and x1, and if f of x0 and f x2 should be less than 0, then the root is going to be lie in between x0 and x1. So these are the three possibility conditions that can able to obtain. So if the f of x0 value should be 0, then the root should be at x0 only, and if f of x0 and x1 is there, then the root is going to be lie in between x0 and x1, and similarly if of x0 and x2 is equal less than 0, then the root is going to be lie in x0 and x2. So let us consider one simple example how we are going to execute this bisection method. So the function is going to be defined as x power 3 minus 5x plus 1. So in this one, so I'm going to calculate the interval in between 0 and 1 here. So in this 0 and 1, so I'm going to substitute the value f of 0, that should be I'm going to get as 1, and similarly if I'm going to insert 1 in the equation, I'm going to get minus 3. So the interval is going to lie in between the sign is not equal here, so the interval contains the root 0 and 1. So because the sign of f of x not sign of f of 1 and 1 should be different here. So in first iteration what I am going to say, so let us consider x1 and x2 should be 1. So calculate the x0 value, that should be x1 plus x2 by 2. So by substituting these values of x1 and x2, I am going to get 0.5. So f of 0.5, that should be minus 1.375. So that's why what I'm going to say, f of x0 and x1 should be less than 0, so the root is going to be lying between 0 and 0.5 only. Okay, in iteration 1, so I'm going to substitute the value of x1 and x2. So after calculating the middle point, I'm going to get 0.5 here. So by substituting this value in equation, so what is the equation? F of x is equal to x cubed minus 5x plus 1. So f of x is equal to x cubed minus 5x plus 1. If I'm going to substitute this 0.5 whole cube minus 5 into 0.5 plus 1, so I'm going to get minus 1.375. So that's why the f of x0 is and f of x1 is less than 0, so that's why the root is going to be lying in between 0 and 1. In second step, if I'm going to consider an x0 as 1, x1 as 0 and x2 as 0.5, if I'm going to calculate this x0 value, I'm going to get 0.25. So therefore x2 is 0.25 by substituting this equation in x cubed minus 5x plus 1. So I'm going to get minus 0.23. So this should be also the f of x0 is 0 and f of x2 here is that minus 0.2, that should be less than 0, that the root is going to lie in between 0 and 0.25. So that is x0 and x2 here. So like this, we are going to be substitute this and values in that equation. So in first I'm going to get x0 as 0.5 and later I'm getting 0.25, and by if I'm going to do like this, so finally here the value is same, so that's why the root is going to be lying in between 0.1875 to 0.218. So this should be the root value of this equation. So what are the advantages here? So it is simple to implement, and once the function evaluation is per iteration only, and the size of interval containing the 0 is going to be reduced after each iteration, and no knowledge of derivative is going to be needed here. So these are the advantages of this bisection method. And similarly, what the advantages means, it is slow to converge and good intermediate approximation may be discarded. So these two will be the disadvantages of this. So if I'm going to take this bisection method, it is simple and easy to implement. So once the evaluation per iteration and the size of interval containing 0 is also going to be reduced after each iteration. And next question is that, so discuss in detail about Newton-Raphson method. So for this, Newton-Raphson is a numerical technique, so which is going to be used to find the root and transcendental equations, and some of this algebraic equations looks like x cubed plus x squared plus x plus 1 equal to 0. So this should be one of the form of this algebraic equation. So this Newton-Raphson is going to be numerical technique which is going to be used to find those roots for algebraic and transcendental equations. So if I'm going to consider this algebraic equation, so I'm going to get, so x power square plus x power 4 plus x square plus 1 equal to 0, or x power 8 minus 1 equal to 0, x cube minus 2x minus 5 equal to 0, like this. And transcendental equations means, so these are the equations where which is of the form of exponential or trigonometric functions here. Okay, so the equation which is going to contain some of the transcendental functions, let be sine, cos, tan, e power x, x power e, and log. So these and all will be called as a transcendental equations. So if the function is going to have this kind of this transcendental equations, how are we going to find this root of this kind of such equations here? So how the graph looks like in Newton-Raphson method is that, so if I'm going to consider x and f of x on y-axis, so by taking the values of xi and xi plus 1, if I'm going to make a slope of that, so I can able to obtain f dash of x here. So if I'm going to take f of x equal to 0, that should be initial given equation, and starting at x naught, so determine the slope of f of x and x equal to 0, what we can able to call as f dash of x naught. So how the slope value, that should be tan value. So how this value is going to be obtained, so f of xi minus 0 by xi minus xi plus 1. So f of xi, and then the summation of this is going to be taken to find the slope of this equation, and finally what we can able to call it as a f dash of xi. So if f dash of x is going to be determined f of x by xi minus xi plus 1, so here what I'm going to say is that so by substituting this value here in this one, so finally I'm going to get xi plus 1. So here in this one, f dash of xi, so how I'm going to get it, xi minus xi plus 1. So how I'm going to get it here, I'm going to find the xi value here. So for this I'm going to take this one first upside, and f of xi by f dash of xi, and finally I'm going to obtain xi plus 1. So xi minus f of xi by f dash of xi, and this should be the Newton-Raphson formula here. Okay, so initial the function is going to be given, that should be the first one, and initial point is going to be stored at x naught, and we have to determine the slope of the equation, so which one able to call as f dash of x, and then finally we have to obtain the slope value, and by substituting this one, so I can able to estimate xi plus 1, that should be the final Newton-Raphson method here. So what is the algorithm for f of x here? So calculate f dash of x symbolically and choose an initial guess, so x naught as given below. Let a comma b be the intervals such that f of a and should be less than 0 and f of b should be greater than 0. Then I'm going to estimate the x naught here. So x naught is equal to a plus b by 2. So whenever this x1 is equal to x naught minus f of x naught by f dash of x naught, similarly I'm going to estimate x2 also. Similar like this, we are going to estimate x3, x4 and x5. So if I'm going to find xi plus 1 is equal to f of x, then we're going to stop it. So hence we are going to find the root of the equation. So if we have the given equation like f of x equal to 0, so then x naught be the approximate root of the given equation. So let the x naught plus h, it should be the actual root, it should be very small such that, and then from the Taylor series expansion we're going to find f of x naught plus h value. So how this equation should be, f of x naught plus h into f dash of x naught plus h squared by 2 factorial f double dash of x naught, and h cube by 3 factorial f triple dash of x naught. So we're going to first find the first approximation should be x1, that should be x naught plus h. So from this I'm going to find x1. So x1 is equal to x naught by f of x naught by f dash of x naught, and similarly x2. So I'm going to repeat this process. Finally I'm going to determine the anti term, that should be xn plus 1, that should be xn minus f of xn by f dash of xn, that should be the required Newton-Raphson method. So if I'm going to have the function like this, f of x is equal to x cube minus 2x minus 5. So if I'm going to derive this f dash of x, so x cube can be written as 3 into x square, and 2x going to be written as 2. So finally this should be the f dash of x. So finally first taking this f of 1 and f of 2 and f of 3. So by substituting f of 1, so I'm going to get 3 into 1 minus 2, f of 1, right? So f of 1 means, so 1 cube minus 2 into 1 minus 5, so 1 minus 7, that should be minus 6. Similarly f of 2 means, So 2 cube minus 2 into 2 minus 5. So 8 minus 4 minus 5. So that should be 8 minus 9 minus 1. Similarly, f of 3. So f of 3 means 3 cube minus 2 into 3 minus 5. That should be 27 minus 6 minus 5. That should be 16 here. So like this I'm going to find f of 1, f of 2 and f of 3. So then the root is going to be lying between 2 and 3. So the initial point should be 2 plus 3 by 2 by 2. So that is we're going to get to 0.5. So according to Newton-Raphson method we are going to obtain the values like this. So if I'm going to take xn plus 1 value, so f of xn minus f of xn by f dash of xn. So initially put the values is 2.5, then I'm going to get the approximate value of this one as 2.164. Similarly, I'm going to estimate x2, x3, x4 and x5. Since the x2, x4 and x5 is equal, then I can able to stop the process and this should be the required equation of the given function here. Then what are the applications of this Newton-Raphson method is that, so this one is going to be used to find the square root of any number, and you can also find the inverse, and you can also find the inverse square root, and you can also find the root of any equation also. Okay, so these are the Newton-Raphson method to find the root, and you can also find the inverse square root, and then you can also find the root of any given equation. When it comes to this limitation, so f dash of x should be the real disaster of this method, and double dash of x causes the solution to diverge, and sometimes it is going to be trapped in local maximum and minimum also. Okay, so f dash of x is the real disaster for this method, and f double dash causes the solution, and sometimes it is also going to be trapped in local maximum and minimum. So next one, explain in detail about regular falsy method. So in this one, so the initial guess we have to be obtained, and linear interpretation have to be known, and then updating intervals and iterative process, convergence and issues. So these are all going to be discussed while in order to find out the regular falsy method. So initial guess is that, so this method is going to be required two guesses, what we are able to call it as x0 and x1, such that so f of x0 and f of x1 has going to have opposite signs, indicating that the root is going to lie in between x0 and x1. And linear interpolation means, so this method is going to be calculate the new estimation, so by using linear interpolation. So how can I able to estimate this? By using this equation. And updating intervals, so if f of x2 has the same size as f of x1, so then the root is going to lie in between x2 and x1, so that if x1 is updated to x2, then so otherwise the root is going to be lie in between x0 and x2. So then iterative process means, so here we have to take the step 2 and 3 is going to be repeated until the desired accuracy is going to be achieved. And convergence means, so this method convergence linearly, which means that the number of correct decimal place roughly doubles the each iteration. And regular falsy can also be failed to converge if the function is going to have very flat slope near root. So overall, the regular falsy is going to be used to find the root of the equations. So whenever the bisection method is too slow, but it is going to be required carefully, the initial guess may not always the convergence. So if I am going to construct this application of this regular falsy, so I am going to find x to the power x equal to 1, so where this is going to be lie in between the interval. And introduction means, so this is one of the breathtaking iterative approach in finding the roots of the nonlinear equation, and the approximated root is going to be found by using straight line or slopes, and it also be noted based on the Bolzano's theorem for continuous functions. So if f of x is a continuous in the interval a comma b, and f of b should be less than 0, then the value of c is going to be belongs to a comma b for which f of c equal to 0. So here I'm going to consider the regular falsy, how the graph looks like this. So here I'm going to have the interval a and b, and f of a and f of b is going to obtain. In between this we're going to be draw the graph. So these are the derivations that are going to be needed for in the regular falsy method, delta y by delta x. So how this delta y is going to be obtained? So f of a minus 0 by f of a minus c, that should be equal to f of b minus 0 minus b minus c. And this is the other form where I can able to substitute these equations, and f of a minus f of b minus f of a minus b, that should be equal to f of a minus 0 by a minus c. Or I can also write it as f of a minus f of b by a minus b, and also I can able to write, so since these two are equal, so I can able to substitute this one here also. So if I'm going to be taken by these values here, and then I'm going to substitute in this one, so how the regular falsy method equation is going to be obtained. So by taking this f of a minus 0 by a minus c and f of b minus 0 by b minus c, if I'm going to consider, so by taking this value, so this is the obtained equation. So from this I'm going to be estimate the c value here. So how this c value is going to be obtained now? So for this I'm going to cross multiply this f of a into b minus c and f of b into a minus c, and again I'm going to consider b into f of a and then c into f of a into f of b and c into f of b, like this I'm going to be taken. So once this one is considered, I'm going to take the common c value. So this one should be the top one, and this should, by taking this common thing, so that should be constant, and this should be the required regular falsy method here. So how the roots is going to be lie if I am going to consider this f of a and f of b values. So according to this regular falsy theorem, so if f of a and f of b is less than 0, then the root exists. So otherwise the root may not be exist here. So it should be based on the values of f of a and f of b only. So the iteration process continues when the root is going to be exist. So let's just take the c value. So if f of c equal to 0, then we can able to stop in the c as the root as well. And if I'm going to find out the value of f of a and f of c should be less than 0, then we have to set the value c to b. Otherwise we have to set the value c to a. So this should be the algorithm where we can able to follow this regular falsy method. Okay, so in regular falsy method, so these are the initial derivatives. You have to be remember this. So this is one derivative, and this is another derivative. So based, or I can also be write it as this one. Okay, by taking these values, I'm going to be estimate this c value here. So in this c value, by solving these equations and all, I can able to estimate the c value here. So once the c value is done, then you have to be know where the root is going to be exist. So if f of a and f of b less than 0, then root exists, otherwise root does not exist here. So the iteration process is that, so if I'm going to take c here, if f of c equal to 0, then we have to be stop it, and if f of a and f of c less than 0, then we have to set b equal to c, else if we have to set a equal to c. So let us consider one of the example how we're going to find through the root of this function using regular falsy method. So I'm going to consider the function as x into e power x is equal to 1, where the limit is 0 and 1. So consider this should be the f of x value, which is going to obtain the a1 as 0 and then b1 as 1. So by substituting these values of f of 0 here, I'm going to get minus 1. Similarly, if I'm going to get f of 1, that should be 1.71. And similarly, if I'm going to take c1, so how I'm going to get the c1 here? So a into f of b minus b into f of a by f of b minus f of a, that should be the required value. If f of c1 is equal to this, then I'm going to get the value as minus 0.4685. Similarly, if I'm going to choose the another thing, so then I'm going to get 0.3679 and 1. So this should be the another interval where I'm going to get it out. So again I'm going to find out the C2 here. So how the C1 is estimated, in similar fashion I'm going to take the C2 also. So C1 value, what I'm going to get is this one. So f of C1 is this one. So change the interval values, so A2 and B2. So initially I'm taking 0 and 1. Now I'm going to consider this one as starting one, and 1 should be the common one. So by substituting this on all values here, I'm going to get this one, C2 value here, and f of C2 I'm going to get it as this. And A3 B3 means, again I'm going to change the interval values. So this should be the starting one, and 1 should be common here. Again I'm going to find the C3 here. Okay, I'm going to get like this, A4 and then B4. So after doing all this one, so I prepared a table. So based on the iterations, and then what are the value of A, B, C and values, and what should be the value of f of c also. So in first case, if A equal to 0 and B equal to 1, the C value what I'm going to get is 0.3, and f of c value is this one. So similarly in interval 2 I find out, interval 3 I find out, interval 4 and 5, 6 and all. If I'm going to look at this, so I'm going to get the A value remains same, and B values also remain same in all this intervals of 8, 9, 10. So the approximation value of C value is this one, and this should be the required truth value of this given equation. Okay. So in this regular policy, so these are the known derivatives, and you have to obtain the C value. So from this C value you have to obtain where the root is going to be lie. So initially I'm going to take a function like x into e power x equal to 1. So initially I have to take the interval as 0 and 1 here. So I have to estimate the C1, and similarly I'm going to calculate the C2 and C3. So if you go on calculating these values and by filling this table, so by observing this you can able to estimate. So all the time the values should be the same for A and B values. So not C value if I'm going to take it here. So what is the C value? So it's 7, 7, 1, 5, 6, 7, 1. So this and all should be the same. Finally this should be the resultant value. Okay. So like this we are going to find out the roots using different Newton-Raphson method and the regular policy bisection method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.